The views expressed on Science for the People are not necessarily the views of this station, its affiliates, sponsors, or advertisers.
This week on Science for the People, we're taking a look at geoengineering, how it might work, and the political and ethical questions surrounding it. Hello and welcome to Science for the People. I'm Rochelle Saunders. With me is Oliver Morton, Essays and Briefings editor at The Economist, who specializes in energy business, climate science and policy, and other green issues. He's also the author of two previous books, Eating the Sun, How Plants Power the Planet, and Mapping Mars, Science, Imagination, and the Birth of a World. He's here today to talk about his most recent book, which is The Planet Remade, How Geoengineering Could Change the World. Oliver, welcome.
Very glad to be here.
So, first of all, how did you get interested in geoengineering?
I became interested in planets first. I wrote my first book, as you just said, about the planet Mars. After I'd written about the planet Mars, I thought, with all due respect to various friends who've written about other planets, that the only other planet that was remotely worth a whole book of my time was the Earth. And so I wrote a book about the least Martian aspect of the Earth, which is why it's green and not red. And that was the book about photosynthesis, eating the sun. And that took me into issues of planetary sustainability and the carbon climate crisis and ways that humans already did and might intervene on a planetary scale. And around that time, the discourse on geoengineering started to perk up again, following an important paper by the Nobel Prize winner Paul Crutzen in 2006. And so that was the time when this book first started percolating through my mind, and it seemed the obvious next step. And more or less 10 years later, it proved out that it wasn't quite so obvious and wasn't quite so next, but it was the step.
So you start the book by asking two questions, and that seems like a good place to start here. So can you give us those two questions and why you think they're important ones to frame the book and the topic?
Sure. There are two questions that I first heard asked by the Princeton physicist and energy policy guru, Rob Socolow. Some years ago, 4 or 5 years ago. And Rob said there are two questions that you can use to sort of like differentiate people thinking about these issues. So the two questions are, do you think the risks of climate change are such that we need to consider fairly serious action? And the second one is, do you think it's hard to get an industrial civilization that encompasses 7 billion people off fossil fuels? And if the answer to those questions are both yes, then you have to think about climate change in a bigger, more expansive way than maybe most of us do most of the time. Now, if you think that there isn't much of a risk to climate change, then obviously you don't worry about it very much at all, but you're wrong. So that's one of the yes-no possibilities, and that's probably an easier one to deal with. It's not to say that we know everything about the risks of climate change, but do we know that there are specific risks? Yes, of course we do. The second one is a little bit less obvious to people, but getting off fossil fuels is really difficult. We've put some effort into it and made some progress, but the world still operates very largely, well over about 80% on the basis of fossil fuels. And although there are really encouraging signals that fossil fuels are getting easier to displace with some forms of renewable energy, it is a very, very long fight. And the idea that we're going to reduce the amount of fossil fuel use dramatically in the next 10 or 20 years is, I think, very far-fetched. Now, if you're not going to do that, then you're beginning to run into the risk of going into or beyond the sort of like 2-degree area, which people worry about. That said, if the way you're going to do that is if all your action is just reducing fossil fuel use. And that's why you need to think about other things. And one of the other things you definitely need to think about, especially in terms of developing countries, is some level of adaptation and of developing in a climate sensitive way. But my argument is one of the other things you have to think about, not necessarily commit yourself to, is geoengineering of various different forms.
That second question you ask about whether or not it's going to be hard, I think it is an important one that we probably don't talk about enough on a day-to-day basis. I mean, we clearly know we need to do something, but we're not really very good at acknowledging that a lot of our lifestyles, especially in the so-called first world countries, are built around fossil fuels. And I want to save the planet, but I also want to be able to jump on an airplane and go and visit my family across the country. So
absolutely. And don't forget that most of the fossil fuel carbon emissions are no longer from from the developed world. I mean, the developed world still has the historical preponderance of emissions, but these days most emissions are from the developing world, and it's very hard to say. There are various ways that the developing world can develop in a less fossil fuel intensive way than the developed world did. But at the same time, there are genuine issues of energy poverty in developing countries. There are something like 1.3, 1.4 billion people who have no light but fire and sun. And those are very legitimate human needs for development that need to be addressed. And I'm absolutely behind the idea that far more of them can be addressed than previously could through renewable means. And through cleaner forms of fossil fuel than coal. But the idea that that as the population goes up and the equitable distribution of energy requires that more of those people have more energy, the idea that we'll be able to simultaneously bring down fossil fuel use by an entirely unhistorically precedented rate of sort of like 4 or 5% a year. I just think that's I think that's far-fetched for all sorts of reasons. I think it's politically very far-fetched.
Yeah, it's pretty hard to point at countries that are trying to develop and get to where we are now and say, don't do it this way. We did it before, but it was bad, so don't do it.
You know, you can look at China, which obviously people do in these conditions, and you notice that China is actually putting huge amounts of money into non-carbon energy sources, such as wind and solar and nuclear. But at the same time, it's also got a lot of carbon-intensive energy sources, and it will decrease the role of coal in its portfolio, I expect, possibly more than we previously thought in the next 10 years. But it's not going to go away.
So it sounds like both of us, at least, agree that this is a hard problem to solve, and so we should probably consider the potential or possibilities of some of the geoengineering strategies. So, first of all, when we use the word geoengineering, what are we actually talking about? I mean, what are we including as being geoengineering?
Well, that's something which is a good way of filling up time at the beginning of almost any meeting on geoengineering, as people argue about this. For me, the key point about geoengineering and I tend to take a rather broad view, which is the view that people took sort of like 10, 15 years ago before things got a bit more fractious. I tend to take the rather broad view that geoengineering refers to big intentional changes in the climate system that happen after the carbon dioxide or other greenhouse gas has been emitted, rather than things that happen before emission. And so that means that you have two quite technologically different strategies, which both fit into that envelope. And one of these is, if you think of the Earth system as having energy coming in from the sun and going back out, comes in as visible light, goes back out as infrared, you can either, to cool the planet, stop some of the visible light coming in, or make it easier for the infrared to get out. And in geoengineering terms, easier for the infrared to get out means actually taking carbon dioxide or other greenhouse gases that are already in the atmosphere and putting them somewhere else. And that's often called carbon dioxide removal, or sometimes also a subset of that is negative emissions. The other option is to stop some of the sunlight coming in, and I tend to call that just sunlight geoengineering. And one way of seeing it is just, if you were looking at the Earth from space, making it look a little bit brighter by making it a bit more reflective to sunlight would be that form of geoengineering. Now, the various ways you might make the Earth brighter, but basically that's it. You either get a little more sunlight bouncing off the Earth, or you have to let a little more infrared out through the atmosphere.
So when did we first start thinking that we might actually be able to modify the global climate in a predictable, purposeful way?
Well, people have actually thought about it for a very long time. It used to be, maybe not global climate, but it used to be a belief of Enlightenment philosophers, many of them, that part of natural providence was that if you behaved right, which tended to mean if you behaved like a civilized European of the 18th century, the climate would be better too. And so you have things, and this belief is actually very strong, very important in North America, where, for instance, Jefferson believes that the reason why the North American climate, this is a widely agreed fact in the 18th century, and probably still in the 21st, that the North American climate is rather harsher and less equable than the European climate. The answer to that is to replace the savage forests of North America with decent farmers who will farm the land, and the climate will improve as you farm the land. And that belief sticks around in America for a long time. The idea of changing the climate on a global level tends to come around more in the late 19th century, when people talk about, for instance, diverting the Gulf Stream or damming the Bering Straits or flooding the Sahara, some of which is below sea level, to create an inland sea that will make North Africa bloom. And those ideas hang around, but they're very sort of like playful ideas. No one's really genuinely planning to do them. They're sort of like thought experiments that make you feel big and strong and sublimely powerful in your engineering way as you think about them. No one's really talking about it seriously until people start noticing that what humans are doing to the climate, as it were, unwittingly or without deliberate intent through the emission of carbon dioxide, might be having an effect. And at that stage in the 1960s, again, you start seeing the idea of geoengineering approaches being tried out. Because if you think about the people writing the first report to a US president that mentions the carbon dioxide greenhouse effect, which is in 1965, in 1965, it doesn't really seem very likely that you're going to go to LBJ and say, we think you should completely change the industrial basis of the US economy. And so instead, they said, well, things you might do about this might include making the surface of the sea more reflective by floating little reflective balls on the surface of the sea. To us, these days, that sounds particularly absurd. It's worth reminding that back then, it sounded kind of strange to think that you would remake the industrial basis of the economy, which is what we are now rather laudably trying to do. The interesting thing to me about this history lesson is that when you move further up, as climate becomes a more and more pressing political problem, as climate is made through political action a more pressing problem, and as the actual effects of climate change begin to be discernible rather than just the prospect of climate change, the discussion on geoengineering very much goes away. And the reason for this, and it's still a strong line of thought today, is that people worry that if you talk about geoengineering, you'll do less of the emissions mitigation that should be your primary concern. And I think that's a real worry, and I think that you have to address it. And certainly for myself and for pretty much everyone I talk to when writing the book, the idea that geoengineering might in some ways be an alternative to emissions reduction is kind of laughable. There are a few people who've said things that lend themselves to that to that interpretation, but by and large, the people who actually work on the science of this, many of whom are far from convinced that it would actually be a good idea, absolutely believe that you should start off by cutting emissions, and that geoengineering is something that might allow you to reduce climate harm more than you can by just reducing emissions, but isn't an alternative to reducing emissions.
So even if we created some sort of geoengineering strategy, this isn't kind of our one kind of easy button save. There's additional work that we would have to do, and we wouldn't be able to get off the path we are now, which is trying to swap our use of fossil fuels to something more renewable.
No, absolutely. And I think this is something, I find the history of the climate change debate absolutely fascinating. One of the things that's fascinating for something that is a really profound shift in the human relationship with the planet that starts sometime, depending quite how you want to measure it, sometime between the 17th and 18th centuries, and which will have implications going on, for hundreds, probably thousands of years to come. This huge shift, crystallizes in political consciousness in a very, very short period. It's really the period from about 1988 to 1998. It's, in fact, the key years from 1988, which is when Jim Hansen gives evidence to the Senate. There's a very hot summer in America, partly because in North America, partly because of an El Nino. There's suddenly the discussion of climate change, of carbon dioxide and climate change, which has been happening in academic circles, sort of break surface. And it's just like 4 years later that we have the UN Framework Convention on Climate Change signed in Rio. And it's just 5 years after that you have the Kyoto Protocol. So in just like 10 years, this has gone from being not an issue to being a major global political project. And that way of doing things sort of like collapsed down the ideas of climate change to sort of like one particular technical problem about emitting carbon dioxide, which turns out to be a very hard technical problem. And one of the things that I think is important about thinking about geoengineering is it doesn't make things simpler. It definitely makes things more complicated, but that's appropriate because climate change is a very complicated part of the human relationship to the planet that should not be thought of as something that can just be sort of like got rid of, but it's something that we have to discuss, to attempt to manage, or at least to limit, and various different ways that we can do that of a very rich tapestry of action. And the idea that you're trying to collapse it all down into saying, well, instead of doing this one thing, we'll do the other one thing, which is a bit easier, does a huge disservice to the richness of that debate, which is a debate that we'll be having, for well after our lives.
So when we think about geoengineering, we usually think about adding something or removing something from one of the layers above us, usually with airplanes. So can you talk us through how that might work?
Sure. Well, I mean, I just mentioned the eruption of Mount Pinatubo, which shows that if you blow up a damn big mountain, you can put millions of tons of sulfur into the stratosphere. It turns out that you can put millions of tons of sulfur into the stratosphere rather more easily with balloons or aircraft. Now, no one has ever developed aircraft specifically to deliver sulfate, or possibly, we'll come on to this, possibly something else into the stratosphere as an objective in itself. I mean, most of flying in the stratosphere is pretty hard because the air is pretty thin. And so most things up there don't do a huge amount. So, I mean, the most famous stratospheric aircraft are reconnaissance aircraft, and the iconic one of these is the U-2 with its sort of like huge wings and relatively low payload. But the idea of building an aircraft similar to that, but able to take up a few tons of payload is by no means far-fetched, and there have been engineering studies on this. And the actual number of flights you might need is really quite small compared to the number of flights that are already being taken. And that's partly a reflection of the fact that it's easy. You mentioned flying to see our relatives. It's easy to forget quite how much flying the world now does. In terms of passenger kilometers a year, there's enough transportation going on in the world, and this figure is, I think, dominated by air travel, to move the entire population of the United Kingdom to the moon. There are sort of like well over 2, maybe now 3 billion air passenger movements a year. The amount of flying we do is quite huge, and the amount of flying that you would need to do to lift some sulfur or some other particles into the stratosphere compared to that background hum, but that background roar of global air transportation is really quite small. It's considerably less than the sort of burden of a single budget airline. So there'd be different sorts of planes, but technically the ability to lift, say, 1 million tons of something into the stratosphere, in the course of a year, and to keep doing that on a regular basis, that's the sort of thing that you might spend 10, maybe outside $20 billion a year on. So it's kind of similar to building one nuclear power station every few years. It's compared to the global costs of changing energy infrastructure, it's really quite small. And that's one of the reasons why people, I think slightly misleadingly, tend to think of this as a cheap option. I say misleadingly because one of the things that fossil fuels teach us is the cost of actually doing something isn't the same as the overall cost of that thing being done. If you burn fossil fuels, it seems very cheap until you see the cost in terms of the externalities to the climate and to the environment in various other ways. Similarly, you have to think about the total systems costs of geoengineering, not just about the costs of lifting things up to the stratosphere. But it is true that the costs of lifting things up to the stratosphere are probably not all that great.
That is one of the, I think, things about geoengineering that makes people probably correctly uncomfortable, is it does seem there's a lot of unknowns to what could happen if we do something on this scale or something in this way.
Well, uncomfortable is a pretty good way of feeling about climate change with or without geoengineering. And one of the things that I find quite useful to remember is that geoengineering is an additional form of climate change, not an antidote in some ways to climate change. So we have quite large uncertainties, as I was saying earlier, about how climate change without any geoengineering plays out. And it's certainly true that there are also uncertainties and things that you would definitely want to do a lot more research on before embarking on any such project, in how geoengineering, how putting little particles into the stratosphere might actually affect the climate. There are various things that they might change the way in which water moves into the stratosphere. It might change the temperature structure of the lower atmospheres of the lower layers of the atmosphere, the troposphere a little. It might probably would catalyze a certain amount of ozone depletion unless you use designs that no one's yet quite thought of, though people are thinking along those lines. So those are a lot of effects. They're not effects that necessarily would lead you to say, if you were just sort of like balancing the positives and negatives, you wouldn't necessarily say that they were showstoppers, but they would certainly be things you'd very much want to investigate. Another thing that people talk about a great deal is that the climate is more than just the average global temperature. And one of the things that geoengineering does is change. Geoengineering of the sort that puts stuff into the stratosphere might do would be to change patterns of precipitation. If you use only a small amount of geoengineering, it's quite possible that those changes aren't particularly dire. They might even conceivably be beneficial, but that's another thing where you need a great deal more work. That said, those are not the hardest problems, I think, with geoengineering, these sort of like geophysical unknowns. The harder problems are sort of like social and political ones. They are problems to do with the fact that different geoengineering agendas might be a source of conflict between different nations, which have different legitimate interests in what's going on. And also there's this very deep thing about how you feel about nature and how you feel about human power in nature. And I'm not as directly moved by those sorts of concerns as some people are, but I absolutely respect that some people have a notion of the sacred in nature that makes them very hard for them to actually envisage some level of human interference, stewardship, call it what you will, taking the very structure of the atmosphere as one of the things that humans might have dominion over.
How many models do we have about the types of geoengineering projects we're talking? For example, putting sulfur into the stratosphere using some kind of airplane over the long term. Models? Yeah, sorry. Like, do we have some idea of what could happen, what the sort of best possible outcome or worst possible outcome are?
There's not a huge amount of research into geoengineering. But there's been a project called GeoMIP, run by Ben Kravitz and Alan Robock, both researchers in the United States. And, that's compared various quite strong geoengineering scenarios. I mean, scenarios where there's quite a strong effect of putting particles into the stratosphere. It's compared what various different climate models find when they do sort of like in the computer experiments like that. And they found broad agreement that sort of on various things that yes, it's possible to offset the global warming due to a given amount of carbon dioxide. In some situations, you don't get a perfect match, so you get less cooling at the poles and more cooling at the equator, but that's somewhat model dependent. You get changes to as I was saying, you get changes to hydrology, though those become very striking if you use a lot of geoengineering. And I think that one of the things that one would want going into this would be to say, to want to do relatively little of this. What you really want to do, if you want to do this at all, is buy a little bit of extra time to make the transition to a non-fossil fuel economy more easily managed and more equitable in terms of how energy ends up distributed among the nations of the world. You don't want, as I say, you absolutely don't want to just think that if I'm doing this, then I can go on emitting as normal. So those sorts of models are out there. Also models of systems where you take carbon dioxide out of the atmosphere, though the effects there don't tend to be, the geophysical effects there don't tend to be quite so marked. And the two things do to some extent go hand in hand, because remember, one of the things about doing the cooling with particles in the stratosphere is that you're only indirectly doing a little bit about the carbon dioxide getting absorbed in the oceans. And so if you're worried, as you should be, about ocean acidification, that gives you another reason why you need to reduce carbon dioxide levels. So to some extent, you can think about the two different forms of geoengineering, were they to be used, as being a near-term and a long-term goal. The near-term is to shave the peak off the temperature rises that we see due to fossil fuel emissions, and the long term, taking carbon dioxide out, is to reduce the overall level of carbon dioxide in the atmosphere that those emissions have caused. Because if you just emit and then stop, the level in the atmosphere drops off a little bit, but then it stays high for thousands, maybe tens of thousands of years, and you might not want the world to sort of like settle into that equilibrium warm place.
Have there been any comparisons run in the models over sort of a model or a series of models where we do geoengineering versus if we do nothing, to see kind of how things end up?
That's what those comparison programs tend to do. They tend to do runs in which geoengineering is used to balance out the increase in carbon dioxide, or a doubled level of carbon dioxide is balanced out by geoengineering, and they compare the doubled or sometimes quadrupled level of carbon dioxide, the planet that you get that way, the greenhouse planet, as it were, with the geoengineered planet. And in the near-term runs, in sort of like runs where you don't have huge amounts of geoengineering, you find some solutions where I think it's fair to say almost every part of the planet is better off in the geoengineered world. But again, the geophysical side of it, the biogeophysical side of it, is only part of it. The question is can you do geoengineering that's safe, which I guess this is what we're talking about with the biogeophysical stuff, but also is it just and is it governable? Will it be done with an adequate care for the people who tend not to be represented in these conversations? And two particular classes of people not represented very directly are poor people and yet to be people. So the poor in the future need to have a voice in how you think about this. And the other thing is, if you don't think that you can set this up in a system that has some chance of being justly governable, in which there's some way of saying that some system of governance can be applied to this, then that would be that would be a very, very risky thing, over and above the sort of like biogeophysical risks, the direct climate risks. If you start putting out systems for fairly radically changing the way the planet works and haven't given any thought to how they might be governed, then I think you're heading down a very dangerous road.
I mean, this is kind of the whose hand is on the thermostat question, really. Who kind of gets to decide what temperature for how long and where these kinds of efforts happen.
That's an image that's used a lot, and I think it's somewhat misleading, because I don't think geoengineering is ever going to have the sort of like precision that we expect from a thermostat. You know, it's more sort of like setting guardrails maybe than using a thermostat, or maybe using a very bad thermostat. But yeah, and I think I first heard this said a few years ago, that the real challenge is building a hand to go on the thermostat. Not assuming that it's going to be an existing hand called the UN or the US or China. Among other things, I think there's a tendency to assume that because geoengineering sounds big and dangerous and high tech, there's a way of assuming that it's the sort of thing that will be done by nations with a proclivity for the big, dangerous and high tech and spectacular. If you see geoengineering as a way of reducing climate harm, and especially if you see these sorts of sunshine geoengineering as more or less the only way of reducing climate harm in the near term, because emissions reduction, even if you do really steep emissions reduction, takes decades to actually go through the system. There's a lot of warming built into the system. So if you see geoengineering as a way of fighting climate change near term, it's really that or adaptation that you can do. And those are both interests that you might expect to be more strongly felt in the places where the harm is more strongly felt, which is to say, by and large, the developing world. So the assumption that somehow geoengineering would be something that the rich capitalist developed world or China would impose on the world, that is a risk. But you also have to bear in mind that it might be something that some parts of the world, some disadvantaged parts of the world, might actively develop an interest in, because if they're feeling the harms of high temperatures and there is a way of mitigating those high temperatures quickly, I think that would be a legitimate interest.
We'll be back with more Science for the People right after this.
Science for the People is a weekly radio show and podcast that explores everyday life from a scientific perspective. We are a member of the Skepchick Network, a collection of blogs, podcasts, and video content focusing on science and critical thinking. To find out where Science for the People airs near you, or to listen to past episodes, check out our website at scienceforthepeople.ca. You'll also find links to support us at Patreon, to connect with us on Facebook and Twitter, and to subscribe to the podcast in iTunes. And now, back to the show.
You're listening to Science for the People. I'm your host, Rochelle Saunders. In your book, you go through a fictionalized scenario of what might happen if not a kind of first world powerful country were to pick up the mantle of veil making and geoengineering, but if a smaller country that has the resources to be able to do it, but kind of starts to do it in a bit of a secret way and then kind of reveals their plans to the world. Mm-hmm. Why did you think it was important to include that kind of fictional what if storytelling in the book?
Well, I think partly I wasn't absolutely clear until I got to that part of the book that I was in fact going to do that, certainly not to the extent that I did. But I think partly what I was just saying about the assumption being that it's going to be big and powerful people who will consider this sort of thing. If you actually look at the world, you're finding that quite a lot of big, powerful nations are not distinguishing themselves by the urgency of their action on climate change. And so it might well be someone else who does it. So I wanted to mess with people a bit from that point of view and to express the point that, you know, if you're thinking about climate change, one of the things you're thinking about is people who are genuinely near term being harmed by it. So that was part of it. The other thing was I needed some sort of, there were various things I wanted to discuss and I needed some sort of scenario. And though in that I do provide a scenario in which that goes off in a kind of hopeful way, I do also provide scenarios in which it goes off really rather badly. It's very clear that even if people, I wanted to make the point that even if people that one had a certain amount of sympathy for, like these sort of like fictitious developing countries who I had take the lead on the subject, even if people that you had a sympathy for were to do this, you would have to bear in mind that things could still go wrong and you would have to try and work out how to avoid those bad outcomes. So I've been, not I think unfairly, but I've been criticized to some extent for being optimistic in my scenario making. And I certainly provided an optimistic version of the scenario, but I did also provide a version of that scenario in which, despite the fact that it's unusual and in a way sort of like pro-poor and empowering in that way, it still all turns out really rather badly. And I think that that's an important thing to remember. You talked earlier about this being an uncomfortable thing to think about. Yeah, it is an uncomfortable thing to think about. I don't think anyone who gets too comfortable thinking about this is, I think, fooling themselves and at risk of fooling others. At the same time, the fact that something's uncomfortable doesn't mean it can't turn out well, and the fact that something's uncomfortable certainly doesn't mean that you shouldn't do it or you shouldn't think about doing it. You know, there are lots of uncomfortable things that we get through. So uncomfortable is not a showstopper. As I say, lack of safety, lack of justice, lack of governance, those are things that I really worry about.
There are kind of two sides to the uncomfortableness that we have about geoengineering. I think one is about, like you said before, the kind of it's natural and we feel weird kind of impacting the planet in a on purpose kind of way at this scale. But I think the other is also an idea that's touched on in this scenario you build, where that a relatively small group of people can make this decision that could potentially have vast, huge impacts on everybody on the planet. Maybe good long term, maybe bad, and maybe it's not even the fact that they created a veil or geoengineered. Maybe it's the political fallout after that that happens. There's this kind of there's both of these discomforts that play in the geoengineering argument.
Yeah, absolutely. But again, this is another way. This is also a discomfort that just plays in climate arguments. A bunch of mill owners in Lancashire and other parts of the north of England decided they really, really liked steam engines for the material trade rather than the water wheels. And they were making very sort of like straightforward decisions about the political economy of their day, and that had huge effects on billions of people later on. People in the Rockefeller Foundation and various other people chose to develop farming systems using new breeds of plant that could tolerate higher levels of fertilizer and higher levels of pesticide, and allowed much higher yield agriculture in various parts of the developing world. And that had huge impacts. I think on balance, you would have to say kind of positive in that avoiding mass starvation is a good thing. And this was one of the reasons, though by no means the only reason, why the world did manage to avoid mass starvation while its population quadrupled during the 20th century. But again, it was the action of small, not particularly accountable groups of people that does these sorts of things. If you have a complex technological situation that really does reach deep into the biogeochemical cycles that run the planet, that reaches deep into the nitrogen cycle, the sulfur cycle, and the one we think about most, the carbon cycle, also the hydrological cycle, there are going to be ways in which small amounts of action are going to have quite large effects. And if you just look at climate change itself, most of the action that's led to this issue has been done by about 2 billion people worldwide and their ancestors. This is another analysis of Rob Sokolow's. You've got about 1 billion people living in the developed world and about 1 billion well-off people in the developing world. And those 2 billion people more or less account for the vast proportion of the greenhouse gases. And, they're not exactly a majority, but they're what the atmosphere sees when it looks at us. So there is this uncomfortable notion that the effects that are shared out not equally among all humanity are also caused not equally among all humanity.
So we talked a little bit before about some of the strategies that we could use if we decided to go forward with some kind of geoengineering strategy. One of them was creating aerosols with sulfur in them. Are there other types of particles that we could use to slow down global warming?
All you need to do, if you're putting something up into the stratosphere, all you need to do to cool the planet is have it be something that reflects sunlight back out into space. The reason why most of the focus has been on sulfur particles, actually sulfate particles, so far, is because that's what nature provides. There's a thin layer of sulfur particles in the stratosphere at all times, and because of sulfur emissions from volcanoes, and it gets thicker after a big eruption. And so that's where scientists first saw the effects of an eruption cooling the planet. And so that's what people first focused on. But more or less anything that you put up, in theory, if you put up something that absorbed sunlight rather than reflected it, you could also cool the surface by putting something into the stratosphere. When I was researching the book, I actually found some calculations from a Cambridge physicist in the early 1950s, before there was any concern about global warming, where he realized that you could change the climate by putting stuff into the stratosphere. And he basically decided he had no idea why anyone would want to do this, but the maths was basically the same as the sort of first order maths that we use to describe the issue today. So sulfur is what nature uses, or what it's the natural analog that we have to mind. But you could think about other sorts of particle. You could think about, and one rather fantastical option has been people have looked at possibly using diamond, dust of diamond. That makes things a little bit more expensive, not that much more expensive. Because, this will also be synthetic diamond. But there might be advantages to that. People have looked at, possibly using particles where the chemistry was designed to have less effect, or no effect on, if possible, on the ozone layer, as opposed to sulfur, which does have a slight have a damaging effect on the ozone layer. That's not the showstopper, by the way, that it might sound, for one reason being that since we stopped emitting chlorine into the upper atmosphere with the ban on CFCs under the Montreal Protocol, the level of chlorine in the stratosphere is peaking and falling away. And so even if you increase the rate at which the chlorine attacks ozone a little bit, you will probably be having less of a net effect as the chlorine itself becomes less of a problem going on into the middle and second part of this century. So you will be more slowing the repair of the ozone layer than damaging it afresh to some extent. So yeah, you could have particles. I mean, I don't think anyone's really begun to do a really systematic look at the different particles you could use. The appeal of sulfur, the two appeals, one is the naturalness I spoke of. The other one is there's a sort of like poetic appeal. I talked earlier about this paper in 2006 by Paul Crutzen, which reignited interest in geoengineering. And one of the reasons was just that Paul Crutzen had been one of the people who had done the original work on the destruction of the ozone layer by human activity and had won the Nobel Prize for it, the Nobel Prize for Chemistry, not the Nobel Peace Prize, though arguably Paul should have got both. And Paul's saying you don't have to worry too much about the ozone layer. You have to keep an eye on it, but it's not a showstopper. That was something that gave people sort of like a sense that geoengineering was something that it was now more permissible to talk about. Another thing, though, that's really interesting about that paper is that Paul pointed out that humans are already emitting a great deal of sulfur into the atmosphere. We're just doing it at low levels through smokestacks, mostly of coal-fired power stations. And that sulfur that's being emitted to the atmosphere at low levels is doing a huge amount of human harm. And it's contributing to well over 1 million, maybe a couple of million deaths a year due to lung infection, to lung disease. It's a terrible thing, and it's something that, in the developed world, we've largely got rid of. We've reduced sulfur emissions hugely over the past couple of generations. China is now trying very hard to reduce sulfur emissions. In general, this is happening. And sulfur in the lower atmosphere also cools the planet. It does it much, much, much less efficiently, because sulfur in the lower atmosphere, although sulfate particles still reflect away sunlight, they last much less long because they get washed out of the atmosphere by rain. And so Paul's idea was that if we are as responsible nations to reduce the amount of sulfur in the lower atmosphere, we will warm the planet somewhat. Because we'll be reflecting back less sunlight out in space. So maybe we should replace the sulfur going into the lower atmosphere with a much smaller but longer lived layer of sulfate particles in the upper atmosphere, in the stratosphere. So this was a rather elegant sort of like trade-off idea that Crutzen outlined, which hasn't really been taken up, but it's certainly true that we are trying very hard in some parts of the world to reduce sulfur, and that sulfur, for instance, from ships at sea, the ever more stringent rules enforced by the IMO on how much sulfur can be emitted by ships in the open ocean, that has a climatic effect. By some calculations, the changes to sulfur emissions by ships at sea may be the biggest direct governmental effect on climate that there's yet been. It's similar in order to the effect that you get from the Montreal Protocol, I think. Given that we're doing that, maybe think about putting a much smaller amount of sulfur higher up to save the cooling effect. It's probably more a neat rhetorical point than it is a real plan of action, but it's one of the reasons why people have concentrated on sulfur as well, because we already know humans are already putting far more sulfur into the atmosphere than any geoengineering scheme could possibly require. They're just doing it at a different part of the atmosphere.
So once we were to create a veil, if we decided to go that way, would we have to keep feeding it forever? I mean, what would happen if we decided to stop?
Well, that depends on the strategy we use, and would depend on what we did at the same time. If you just go on emitting, which, as said right at the beginning of this conversation, is not a good idea. But if you went on emitting carbon dioxide and went on and kept on building a veil and then for some reason stopped, then the warming or heating or boiling due to all that carbon dioxide would very suddenly come into play. But there's been some interesting work recently on this by some researchers I know, Peter Irvin and Andy Parker, pointing out that if the effect of stopping doing the geoengineering was really, really that bad, then the likelihood is people wouldn't stop. The idea that just because we can imagine people stopping something doesn't mean that that's really a plausible thing that might happen. It's just a sort of like scenario that you conjure up, and you might conjure up a scenario in which people stop emitting carbon dioxide, but as we talked about at the beginning, that's a hard thing to do. It might prove very difficult to stop geoengineering if there was a terrible if there would be a terrible result after that. My own preference would be don't do so much geoengineering that this becomes a big problem in the long run. So, for instance, you could do geoengineering in such a way as you reduced by, say, half the amount of warming that you would expect from the carbon dioxide emitted in a given decade. And that would naturally taper off as carbon dioxide emissions tapered off. And then you would have a system whereby in the end you'd have, as it were, a soft landing, whereby because there's no more net emission, there's no more geoengineering, and the climate comes to a sort of like stable position until maybe you start taking carbon dioxide out of it. The scenario I use in my book is one of just sort of like trying to limit the absolute extent of warming in any given decade. And again, you would have to do that for a very, very long time before you ran into these really nightmare scenarios in which you suddenly get 2 or 3 degrees of warming in a decade from stopping a very, very powerful geoengineering project. I mean, the best way to avoid that problem is to never have a really, really powerful geoengineering project. And I think that would be what most people would prefer. Most people would like to see, if they want to see any geoengineering at all, and if it meets their criteria for being socially responsible, they would still not want to see very much of it, partly for the reason that, sort of like technological things can, under some circumstances, be rather brittle.
So our governments are sort of inherently short-term creatures. I mean, they're only elected for a very short time, and they're very focused on trying to get reelected in the short time that they have the ability to run the government. And on a longer scale, I mean, we only live a very short time. Given the longer scales that these kinds of projects and ideas are trying to tackle, do you think governments will ever be spurred into action, or maybe will be spurred into action with enough time for money funded into research to actually make a difference?
I honestly don't know. Governments do research on some fairly long-term thing. Governments have sort of like found themselves able to make plans for hundreds to thousands of years when it comes to dealing with nuclear waste. Some governments have done that rather more successfully than others. And as is so often the case, it turns out that, the basic solution to most of humanity's problems seems to be start off by being Scandinavian and it will all go a bit better. In general, governments can do some long-term things. And one of the problems, I think, is that governments have become quite good at long-term thinking about the military. I remember Clive Hamilton, who's a trenchant critic of geoengineering, who I like and admire. Clive was making the point to me a while back that the word strategy has almost been entirely colonized by the military, that strategic concerns are military concerns. And of course, somewhere about 300 kilometers from here, I can't remember exactly where, the British government is building a pair of aircraft carriers, which it fully expects to have on the high seas in the 2050s. So when it comes to making decisions about power stations or about nuclear weapons or about aircraft carriers, people are capable of perspectives that last them sort of like well into the second half of the 21st century. So it's not like there's everything that a government does is always limited to 5 years. So, for instance, we're seeing large amounts of infrastructure being put into London, big new sewerage system, big new railway systems, the benefits of which Londoners will be feeling throughout the 21st century. So, although it's definitely difficult to get governments to look at really long-term things, I don't think it's absolutely impossible. But I quite take the spirit of your question, which is, given that climate is already so difficult, given that the benefits of acting on climate tend to be felt by people who are a long way off in time and space, it is very difficult getting governments to think seriously about climate. And given the fact that geoengineering is likely to remain, for the reasons we've touched on, a kind of controversial technology for some time to come, it would be surprising if it actually was easy to get governments to do it. And it would be actually disturbing if it was easy to get governments to do it. This is an idea that needs to be tried out. You need to have the debates. You need to actually have arguments. Just getting someone to sort of like sign a check and say, okay, we'll do that next Tuesday, would not be my idea of success.
I guess my cynicism comes in when I think about governments and long-term projects and infrastructure projects, is that quite often governments can think long-term about an infrastructure project, but usually that long-term thinking is prompted by a current emergency or a current urgency. So a sewer system doesn't get replaced before it hits capacity. It gets replaced sort of as capacity is hit and starting to cause people real problems.
Yeah. No, I think that's entirely true. I think that's entirely true. And that's actually one of the reasons for thinking that some of the more impassioned debate about this may happen in places that suffer more severe climatic effects than temperate Western Europe, where I live. It might be. So I agree. There is a way of thinking about geoengineering, which I actually go out of my way to try and render problematic in the book, which is that it's sort of like an emergency option, that you do normal emissions control unless things get really, really, really bad, in which case you sort of like break the glass and use the geoengineering. I don't like that way of looking at it for various reasons. One is that I think that it requires that you start off geoengineering at a time when everyone's completely panicked and when the system is already behaving oddly, and you have to start off with a lot of geoengineering from day one because it's an emergency. And it's also, the whole idea of an emergency in political science is kind of the idea of a time when normal governance breaks down. And I don't want normal governance to break down. That said, things getting worse for particular places and particular people might be one of the things that drives the debate about geoengineering further up the agenda for at least some governments.
Definitely feels a little bit like a rock in a hard place.
No, that is definitely true. I mean, I have no idea how it plays out, but I do think you have to bear in mind the possibility that, seen from the far end, however that might play out, people will be looking back and saying, I'm really surprised they didn't talk about that more. Now that we know X and Y and Z, I'm surprised they didn't talk about that more. So I just wanted to make sure that people get the chance to talk about it.
Oliver, it's a really interesting, excellent book. Thank you so much for coming on today.
I'm delighted. It was lovely talking to you, Rochelle.
And if you want to learn more about Oliver Morton or his book, The Planet Remade, How Geoengineering Could Change the World, we have links to get you started on our website, which is scienceforthepeople.ca. Before we go, we wanted to tell you about an upcoming event we think you might be interested in. Joining me to tell you about it is Ryan Consell, a writer for Mad Art Lab, which is a member of the Skepchick Network, where he blogs about the intersection of art, science, and geek culture. His areas of focus include materials science, costuming, and their depictions in popular media. And he's popped in to tell us about Skepchickcon, an upcoming event that may be of interest to you. Ryan, welcome back.
Thank you very much.
So, first of all, what is Skepchickcon?
Skepchickcon is the science and skepticism and feminism track that goes on and is organized by the Skepchick Network at CONvergence, which is a bigger nerd convention that happens in Minnesota in the summer.
So maybe tell us a little bit more about the kinds of programming people can expect to see at Skepchickcon, and then also a little bit more about CONvergence, because it's kind of like two cons at once, kind of.
That is very true. And CONvergence is a brilliant con, so I'll tell you about that second. So the kind of programming that Skepchick puts on, it goes all over the place. If you've ever been to any of these Skepchick sites, we try to cover a bit of everything. So there's a bit about art and science. There's a little bit about education. There's a lot about feminism and rationality and the intersection of the two. And there's a bunch of just pure science tracks or science panels where we talk about space and chemistry.
That sounds fantastic. That sounds like exactly the kind of thing that is up my geeky alley. So what about CONvergence?
CONvergence is a wonderful format of a convention. It happens around the July 4th weekend, again, down in Minnesota. And it's a collection of thousands of nerds, many of whom are in costume. And it's all about just celebrating whatever facet of geekdom happens to appeal to you. And CONvergence, unlike many of the sort of Comic-Con-like conventions, is more about those panel talks and those small salons and places where you can hang out and meet other nerds that share your nerddom. And it's a really cool and progressive and explicitly accepting space. So they go to a lot of effort to make it safe and open for every type of person to come.
That sounds super awesome. It sounds like basically my kind of geek mecca, honestly.
You would have a fantastic time.
Sounds like most of our listeners would have a fantastic time there as well. So I'm always intrigued. I've never had a chance to go to CONvergence or Skepchickcon myself. And, I'm one of those people that when I go to a conference or a convention, I'm super into the panels, the big events that happen in the big, like, stages and the big theaters. I honestly can skip. It's all the, like, panels and the interesting topics that you get 4 people together or 5 people together in a panel to talk about. Those I find are always the most interesting things.
Oh, then you would hate this con because you have to pick between 4 or 5 of those every hour.
Oh, so hard.
Yeah, it's the amount of programming and the quality of programming that they managed to put on is incredible. Like, they have our science track, which runs all weekend, but coupled with that, we also put on salons where you can come and sort of speak to a smaller group of people on a thing, or a little lab. We've done glow-in-the-dark biology before, where you make a cool little petri dish full of bioluminescent algae. And then there's like kids' craft rooms running all weekend, where we've helped run like bug activities, which are great. And then there's a couple big event things, but I've never been to them because I'm too busy at the panels.
So for panels, can you maybe give us some, I know that the programming for this year isn't finalized yet, but can you give people a taste based on what has happened in previous years for some of the panels?
Sure. Just running through some ones in the past. There's been talks about molecular biology and what it means to you, poisons and forensic science, bad science in science fiction movies, and moving more away from science, we've had things like talking about consent and consent in media and how to be good partners with people. Talking about materials and tools in cosplay, nightmares and the science around that, and making necklaces that look like DNA.
Those sound awesome. And for any listeners out there who are interested in hearing the types of panels you can expect to hear at Skepchickcon, if you go back in our archives, you can listen to How to Get Away with Murder, which was a fantastic and hilarious panel from Skepchickcon that we recorded and that our own Desiree Shaw moderated. We had a panel on mental health that was really excellent. And I believe you, sir, were on a panel about the future of cities.
Yeah. 2 years ago, we had a wonderful panel discussion about what our cities might look like in 10 years, 50 years, what technology might change, and whether we're living in a post-apocalyptic wasteland or a science fiction utopia.
And of course, you can find all 3 of those ones that we just mentioned in our archives if you want to hear the type of stuff that you can expect to hear at Skepchickcon if you are available and able to go. And additionally, for anybody who's interested, the current plan is for our own Desiree Shaw to go back to Skepchickcon this year and record a bunch more new panels, which we're super excited about. No spoilers yet because it's not finalized, but we're hoping we'll have some really excellent panels that we can share with everybody in the fall. So one last time before we sign off, when is it?
It is June 30th to July 3rd.
And where is it?
It is in Minneapolis, Minnesota.
And if people want more information because they're super excited and want to learn more, where should they go?
www.convergence-con.org.
Ryan, thanks so much for popping by.
Thank you for having me, Rochelle.
And of course, we will have links to CONvergence and to the Skepchickcon track in our show notes for this episode, which you can find on our website, scienceforthepeople.ca.
Science for the People is produced by Rochelle Saunders and edited by Ryan Bromsgrove. Helen Quivalon is our publishing liaison. We get research help from Josh Whitten. Coordination and additional behind-the-scenes support comes from the enthusiastic Skepchick Network team. Our theme song was written and recorded by Fractal Pattern, and its title is Binary Consequence. Science for the People is listener-supported. You can find us on Patreon, where you can support us with monthly donations in any amount. In return, we regularly post special patron-only extra content and after-show casual conversations with guests. This show is created in partnership with the Skepchick Network, a collection of blogs, podcasts, and video content focusing on the intersection of science, popular culture, politics, and social justice. You can find out more about Skepchick at skepchick.org. The show is hosted by Rochelle Saunders and me, Desiree Schell.